Hi, Math 43. We had some questions on problem 3 in homework 3B. So I noticed we have monthly maintenance costs on an apartment complex fit a bell-shaped distribution. So that'll be significant. Remember, bell-shaped looks kind of like a bell. And we know that the mean is 250 and the standard deviation is 50. And we're going to use the empirical rule to find the following. So you can find the empirical rule in the beginning of section 3.5. So the empirical rule told me percents. If you look at the beginning of 3.5, we know that it's one standard deviation from the mean was around 50 to 80% for most data. Or with bell-shaped, we get a nice special case where it's 68% approximately. So we can make better predictions with bell-shaped because they're all the same shape, versus most data, the shapes will vary. 2 standard deviations from the mean we learned was, I think, around 90 to 100 for most data sets, and then it was around 95 for bell-shaped data sets. And then 3 standard deviations would be almost 100. So basically almost all, and then we learned specifically for bell-shaped, it was very specific and 99.7. So what we're going to try to do is relate these range of numbers to standard deviations. So for the first one, we have percent of months that have maintenance costs from 200 to 300. So we're going to basically do like those ranges we were doing, but backwards. So what I notice is 200 would be 250 minus 50. I like those numbers because that's my mean and standard deviation. And I notice 300 would be 250 plus 50. So that's the mean plus or minus 1 standard deviation. And so since this is bell-shaped data, we know that this is around 68%. If we didn't know bell-shaped, then it could be a variety of percents between 50 and 80. But bell-shaped, we can get more specific. And then what about 150 to 350 for part B? So what I notice is 150, again, I want to use the 250 because that's the mean, would be 250 minus 100, which would be the same as 2 times 50. So that would be 2 standard deviations. Let's see if the 350 does the same thing. So 350 would be 250 plus 100, and yeah, plus 100 would be 2 times 50, so that's 2 standard deviations. So we're trying to relate these range of numbers to the mean and standard deviation. And then since this is bell-shaped data, and it's 2 standard deviations from the mean, we know it should be around 95%. And that's it. So hopefully this helps understand the empirical rule a little bit.